weeks I started a new job, so I've been trying to find time to post my videos, and today has been actually the first time in almost a week that I've been home, other than coming home yesterday for a few hours to take a shower and then take off. But yeah, it's been almost a whole week since I've been home. So today our first video, today our live stream video is about the Ice Age. An ice age is during this time frame is a period of time when the lower temperature of Earth's surface and atmosphere resulted in the presence or expansion of continental and polar ice sheets and alpine glaciers. Now, the term is applied in several different major senses to very long and comparatively short periods of cooling. Like the colder periods are called glacial or ice ages, and warmer periods are called interglacials. Let's check something out here for a minute. Um, I don't think it's it. Maybe. Okay, that works. Okay. Now, the Earth's climate alternates between ice house and greenhouse periods, and it's based on whether there are glaciers on the planet. Now, for the most part of Earth's history, it's been in a greenhouse period with little or no permanent ice at all. Now, over the very long term, Earth is currently in an ice age period called the late Cenozoic Ice Age, which started 34 million years ago. Let me go write that down so I can look up something like that down the line here. Okay. Yeah, so the Cenozoic Ice Age started 34 million years ago, and this term is also applied when there have been colder and warmer periods within this ice age, and the term is also applied to the glaciation, which started over 2.58 million years ago. Now, within this period, the last interglacial ice age period ended about 115,000 years ago, and it was followed by the last glacial period known as the LGP, which gave way to the current warm Holocene, which started 11,700 years ago. Now the mo- Now the most severe cold period of the LGP was the last glacial maximum, which reached its maximum between 26,000 and 20,000 years ago. And the most recent glaciation was the Younger Dryas between 12,800 years ago and 11,700 years ago. Let's scroll down here for a minute. Now, so in 1742, Pierre Martel, who was an engineer and geographer living in Geneva, had visited the valley of Chamonix in the Alps of Savoy. Now, 2 years later, he basically published an account of his journey through the Ice Age. He reported that the inhabitants of that valley attributed the dispersal of erratic boulders to the glaciers, saying that they had once extended much further. Now, later, similar explanations were reported from other regions of the Alps. In 1815, the carpenter and chamois hunter Jean Pierre Perraudin explained erratic boulders in the Val de Bagnes in the Swiss canton of Valais as being due to glaciers previously extending further out. An unknown woodcutter from Meiringen in the Bernese Oberland Oberland advocated a similar idea in discussion with the Swiss German geologist Jean de Charpentier in 1834. Now, comparable explanations are also known from the Val de Ferret and the Valais and the Sealand in western Switzerland, and Goethe's scientific work. Now, such explanations could also be found in other parts of the world. When the Bavarian naturalist Ernest Bibra visited the Chilean Andes in 1849 and 1850, the natives attributed fossil moraines to the former action of glaciers. Now, I don't know how true that actually is, but there's different theories as to how this ice age shit started. Now, meanwhile, European scholars had begun to wonder what had caused the dispersal of erratic material, and from the middle of the 18th century, some discussed ice as a means of transport. The Swedish mining expert Daniel Talas was in 1742 the first person to suggest drifting sea ice was a cause of the presence of erratic boulders in the Scandinavian and Baltic region. In 1795, the Scottish philosopher and gentleman naturalist James Hutton explained had explained erratic boulders to the Alps through the action of glaciers. 2 decades later, in 1818, the Swedish botanist Goran Wallenberg had published his theory of a glaciation of the Scandinavian peninsula. He regarded glaciation as a regional phenomenon. Now, only a few years later, the Danish Norwegian geologist Jens Esmark had argued over a sequence of worldwide ice ages. Um, In paper published in 1824, Esmark proposed changes in climate as the cause of those glaciations. He attempted to show that they had originated from the changes in Earth's orbit. Now, Esmark discovered the similarity between moraines near Hawk, Hawk, Hawkalevatnet Lake near sea level and Rogaland, and moraines of branches of Josta Delsbreen, which I'm not sure if I'm saying those names right. Now, Esmark's discovery were later attributed to or appropriated by Theodore Kirchhoff and Louis Agassiz. And you can see this here. This picture was something during the Ice Age above sea level, and this is where Jen Esmark had discovered similarities to moraines near existing glaciers in the high mountains. Now, during the following years, Esmark's ideas were discussed and taken over in parts by Swedish, Scottish, and German scientists. At the University of Edinburgh, Robert Jameson basically seemed to be relatively open to Esmark's ideas, as reviewed by Norwegian professor of glaciology Bjorn Anderson in 1992. Jamison's remarks about ancient glaciers in Scotland were most probably prompted by Esmark. Now, in Germany, Albrecht Bernhardi, a geologist and professor of forestry and at an academy in adopted Esmark's theory. In a paper published in 1832, um, Bernardi speculated about the polar ice caps once reaching as far as the temperate zones of the globe. In Val de Bagnes, a valley in the Swiss Alps, there was a long-held local belief that the valley had once been covered deep in ice. And in 1815, a local chamois hunter called Jean-Pierre Perraudin attempted to convert the geologist Jean de Charpentier to the idea, pointing to deep striations in the rocks and giant erratic boulders as evidence. Charpentier held the general view that these signs were caused by vast floods, and he rejected Perraudin's theory as absurd. In 1818, the engineer Ignaz Benetz had joined Perraudin and Charpentier to examine a proglacial lake above the valley created by an ice dam as a result of the 1815 eruption of Mount Tambora, which had threatened to cause a catastrophic flood when the dam broke. Perraudin attempted unsuccessfully to convert his companions to his theory, but when the dam finally broke, there were only minor erratics and no striations, and Benetz concluded that Perraudin was right and that the only ice could have caused such major results. In the year 1821, he read a prize-winning paper on the theory to the Swiss Society, but it was not published until Charpentier, who had also become converted, published it with his own more widely read paper in 1834. In the meantime, the German botanist Carl Friedrich Schimper was studying mosses which were growing on erratic boulders in the alpine upland of Bavaria. He began to wonder where such masses of stone and had come from. Now, during the summer of 1835, he made some excursions to the Bavarian Alps. Schimper came to the conclusion that the Ice Age must have been the means of transport for the boulders in the Alpine upland in the winter of 1835 and 1836. He held some lectures in Munich. Schimper then assumed that there must have been global times of liberation with a cold climate and a frozen water. the Ice Age. Champier spent the summer months of 1836 at Devens, near Bex in the Swiss Alps, with his former university friend Louis Agassiz and Jean de Charpentier. Champier, Charpentier, and possibly Bonnet convinced Agassiz that there had been a time of glaciation. Um, During the winter of 1836 and 1837, Agassiz and Champier developed the theory of a sequence of glaciers. They mainly drew upon the preceding works of Bonnet, Charpentier, and on their own fieldwork. Agassiz appears to have been already familiar with Bernardi's paper at that time, and at the beginning of 1837, Champier coined the term Ice Age for the period of the glaciers. In July of 1837, Agassiz presented their synthesis before the annual meeting of the Swiss Society for Natural Research, and the audience was very critical, and some were opposed to the new theory because it contradicted the established opinions on climatic history. Now, most contemporary scientists had thought that Earth had been gradually cooling down since its birth as a molten globe. In order to persuade the skeptics, Agassiz embarked on geological fieldwork. He published his book study on glaciers. In 1840, Charpentier was put out by this, as he had also been preparing a book about the glaciation of the Alps. Charpentier felt that Agassiz should have given him precedence, as it was he who had introduced Agassiz to the in-depth glacier research. Now, as a result of personal quarrels, Agassiz had also omitted any mention of Champier in his book. It took several decades before the Ice Age theory was fully accepted by scientists, and this happened on an international scale in the second half of the 1870s, following the works of James Croll, including the publication of Climate and Time and their geological relations in 1875, which provided a credible explanation for the causes of the Ice Age. Now, there are three main types of evidence for discussing the Ice Age. You got geological evidence, chemical evidence, and paleontological evidence. Now, geological evidence for Ice Age comes in various forms, including rock, scouring and scratching, glacial moraines, drum lines, valley cutting, and the deposition of till or tillets and glacial erratics. Successive glaciations tend to distort and erase the geological evidence for any earlier Ice Age glaciers, making it difficult to interpret. Successive glaciations tend to okay, yep, I've just read that. Sorry. Furthermore, this evidence is difficult to date back to exactly the time frame of when it started. The early theories assumed that the glacials were short compared to the long interglacials, and the advent of sediment and ice cores revealed the true situation. Glacials are long, interglacials are short. It took some time for the current theory to be worked out. Now, the chemical evidence mainly consists of variations in the ratios of isotopes and fossils that are present in sedimentary rocks and ocean sediment cores. Um, Now, for the most recent glacial periods, ice cores provide climate proxies, both from the ice age itself and from atmospheric samples provided by included bubbles of air. And because water containing lighter isotopes has a lower heat of evaporation, its proportion decreases with warmer conditions, and this allows a temperature record to be constructed. Now, this evidence can be confounded, however, by other factors recorded by isotope ratios. Now, the paleontological evidence consists of changes in the geographical distribution of fossils. Now, during a glacial period, that's referred to as cold adapted organisms spread into the lower altitudes, latitudes, and organisms that prefer warmer conditions become extinct or retreat into lower latitudes. This evidence is also difficult to interpret because it requires one, sequences of sediments covering a long period of time over a wide range of latitudes and which are easily correlated. Two, ancient organisms which survive for several million years without change and whose temperature preferences are easily diagnosed, and three, the finding of the relevant fossils. Now, despite these difficulties, um, the analysis of ice core and ocean sediment cores, it's provided a credible record of glacials and interglacials over the past few million years. These also confirm the linkage between ice ages and continental crust phenomena, such as glacial moraines, drum lines, and glacial erratics. Now, hence, the continental crust phenomena are accepted as a good evidence of any earlier ice ages when they are found in layers created much earlier than the time range for which ice cores and ocean sediment cores are available. Now when it comes to the to the world, there have been at least five major ice ages in Earth's history: the Huronian, the Cryogenian, the Andean Saharan, the late Paleozoic, and the last quarter and the latest Quaternary ice age. Um, okay, so I guess I got to write those down. Outside of these ice ages, Earth was previously thought to have been ice-free even at high latitudes. Such periods are known as greenhouse periods. Now, however, other studies dispute this, finding evidence of occasional glaciations at high latitudes, even during apparent greenhouse periods. So let's go write this down so I can actually look this up for next week. Uh, and then we got yeah, so outside of the Ice Age, the only other major things that the world has ever had has been wars, and we'll get to that in another story down the line. Um, so rocks from the earliest well-established ice age called the Huronian had been dated to around 2.4 to 2.1 billion years ago during the early Proterozoic Proterozoic eon. Several hundreds of kilometers of the Huronian supergroup are exposed 10 to 100 kilometers north of the north shore of Lake Huron, extending from the extending from near Sault Ste. Marie to Sudbury, northeast of Lake Huron, with giant layers of now lithified till beds, dropstones, barbus, outwash, and scored basement rocks. Correlative Huronian deposits have been found near Marquette, Michigan, and correlations have been made with the Paleo Protero Zoic glacial deposits from Western Australia. The Huronian Ice Age was caused by the elimination of atmospheric methane, a greenhouse gas during the Great Oxygenation Event. Now, the next well-documented ice age, and probably the most severe of the last billion years, occurred from 720 to 630 million years ago, the Cryogenian period, and may have produced a snowball Earth in which glacial ice sheets reached the equator, possibly being ended by the accumulation of the greenhouse gases, such as CO2, produced by volcanoes. Now, the presence of ice on the continent and pack ice on the oceans would inhibit both silicate weathering and photosynthesis, which are the two major sinks for CO2 at present time. It has been suggested that the end of this ice age was Ediacaran commercial, and nobody knows really what happened there. Now, the Andean Saharan occurred from 460 to 420 million years ago during the late Ordovician and the Silurian period. The evolution of land plants at the onset of the Devonian period caused a long-term increase in planetary oxygen levels and the reduction of the CO2 levels, which resulted in the late Paleozoic Ice Age. Now, its former name, the Karoo glaciation, was named after the glacial hills found in the Karoo region of South Africa. Now, there were extensive polar ice caps and intervals from 360 to 260 million years ago in South Africa called the Carboniferous and early Permian periods. Correlatives are also known from Argentina, also in the center of the ancient supercontinent Gondwana, whatever the fuck you say that. Now, although the Mesozoic era retained greenhouse climate over its time span and was previously assumed to have been entirely glaciation free, but more recent studies suggested that brief periods of glaciation occurred in both hemispheres during the early Cretaceous period. Now, geologic and paleo and climatologist records suggest the existence of glacial periods during the Valentinian, the Hotuberian, and Aptian stages of the early Cretaceous. Now, ice-rafted glacial dropstones indicate that in the northern hemisphere, ice sheets may have extended as far south as the Iberian Peninsula during the Hotuberian and Aptian. Although ice sheets largely disappeared from Earth for the rest of the period, potential records from the Turonian, otherwise the warmest period of the Phanerozoic, are disrupted. Ice sheets and associated sea ice appear to have briefly returned to Antarctica near the very end of the Maastrian, just prior to the Cretaceous Paleogene extinction event. Now, the Quaternary glaciation or the Quaternary Ice Age started about 2.58 million years ago at the beginning of the Quaternary period, when the spread of ice sheets in the northern hemisphere began. Now, since then, the world has seen cycles of glaciation with ice sheets advancing and retreating at 40,000 and 100,000 year timescales, called glacial periods. Glacials are glacial advances, and interglacial periods. Interglacials are glacial retreats. Now, Earth is currently in an interglacial, and the last glacial period ended about 11,700 years ago. All that remains on the continental ice sheets are Greenland and Antarctic ice sheets and smaller glacials such as on the Baffin Island. I don't think I've ever fucking heard of Baffin Island or where the fuck that is. Okay, so the definition of the Quaternary as beginning about as about 2.58 billion years ago was based on the formation of the Arctic ice cap. The Antarctic ice sheet began to form earlier at about 34 million years ago in the mid-Cenozoic Eocene Oligocene boundary. The term late Cenozoic Ice Age is used to conclude this early phrase. Ice ages can be further divided up by location and time. For example, the name Riss dates back to the year 180, dates back to 180 to 330,000 years tops, and Worm 70,000 to 10,000 years refers specifically to glaciation in the Alpine region. The maximum extent of the ice is not maintained for the full interval, but the scoring action of each glaciation tends to remove most of the evidence of prior ice sheets almost completely, except in regions where the later sheet does not achieve full coverage. Now, within the current glaciation, more temperate and more severe periods have occurred. The colder periods are called glacial periods, and the warmer periods interglacial, such as the Eemian stage. Now, there's evidence that similar glacial cycles occurred in previous glaciations, um, including the Andean Saharan and the late Paleozoic ice house. The glacial cycles of the late Paleozoic, also ice house, are likely responsible for the depositions of the cyclothems. Now, glaciers are characterized by cooler and drier climates over most of Earth and large land and sea ice masses extending outward from the poles. Mountain glaciers and otherwise unglaciated areas extend to lower elevations due to lower snow line. Sea levels drop due to the removal of large volumes of water above sea level and ice caps. Now, there is evidence that ocean circulation patterns are disrupted by glaciers. Now, the glacials and interglacials coincide with changes in orbital forcing of climate due to the Mila-Konovich cycles, which are periodic changes in Earth's orbit and the tilt of Earth's rotational axis. Fuck, I'm sweating a little bit. Now Earth has been in an interglacial period known as the Holocene for the last 11,700 years. Now, and an article in Nature and Tells and Report argues that it might be most analogous to a previous interglacial that lasted 28,000 years ago. Now, predicted changes in orbital forcing suggest the next glacial period would begin at least 50,000 years from now, and moreover, anthropogenic forcing from increased greenhouse gases is estimated to potentially outweigh the orbital forcing of the Milankovitch cycles for hundreds of thousands of years from now. Oh, shit, hold on. Fucker. Okay, so each glacial period is subject to positive feedback mechanisms, which makes it more severe, and negative feedback, which dampens the overall climate response to different types of forcing. In the case of quaternary ice ages, Earth's high albedo from ice sheets and atmospheric dust, as well as low concentrations of atmosphere, contributed to cold glacial climates. So an important form of feedback is provided by Earth's albedo, which is how much of the sun's energy is reflected rather than absorbed by Earth. Ice and snow increase Earth's albedo, while forces reduce its albedo, which I didn't know about that. Okay, so when the air temperature decreases, ice and snow fields grow and they reduce forest cover. This continues until completion, with the negative feedback mechanism forces with the negative feedback mechanism forces the system to an equilibrium. So one theory to this is that when glaciers form, two things happen. The ice grinds rocks into dust, and the land becomes dry and arid. And this allows winds to transport iron-rich dust to the open ocean, where it acts as a fertilizer that causes massive algal blooms that pulls large amounts of CO2 out of the atmosphere. And this in turn makes it even colder, and it causes and this even causes the glaciers to grow more and more. In 1956, Ewing and Dunn hypothesized that an ice age, ice-free Arctic Ocean leads to increased snowfall at the high latitudes. When low temperature ice covers the Arctic Ocean, there is little evaporation of sublimation, and the polar regions are quite dry in terms of precipitation. And this is comparable to the amount found in mid-latitude deserts. Now, this low precipitation allows high latitude snowfalls to melt during the summer, and an ice-free Arctic Ocean absorbs solar radiation during the long summer days, and it evaporates more water into the Arctic atmosphere. Now, with higher precipitation, portions of the snow may not melt during the summer, and so glacial ice can form at lower altitudes and more southerly latitudes, reducing the temperature over land by increased albedo, as noted above. Now, furthermore, under this hypothesis, the lack of oceanic pack ice allows increased exchange of waters between the Arctic and the North Atlantic Oceans, now warming the Arctic and cooling the North Atlantic. The current projected consequences of global warming include a brief ice-free Arctic Ocean period by the year 2050. Now, additional fresh water flowing into the North Atlantic during a warming cycle may also reduce the global ocean water circulation, such a reduction by reducing the effects of the Gulf Stream it would also have a cooling effect on northern Europe, which in turn would lead to increased now such a reduction by reducing the effects of the Gulf Stream would have a cooling effect on northern Europe, which in turn would lead to increased low latitude snow retention during the summer. Now, it also has been suggested that during an extensive glacials may move through the Gulf of St. Lawrence, extending into the North Atlantic Ocean far enough to block the Gulf Stream. And there's also been negative feedback on the ice ages. Now, ice sheets that formed during the glaciation period erode the land between beneath them. Now, this can reduce the land area above sea level and thus diminish the amount of space on which ice sheets can form. Now, this mitigates the albedo effect, as does the rise in sea level that accompanies the reduced area of ice sheets, since open ocean has a lower albedo than feedback mechanism as the increased aridity occurring with glacial maxima, which reduces the precipitation available to maintain glaciation. The glacial retreat induced by this or any other process can be amplified by similar inverse positive feedbacks, as for glacial evidence. According to research published in Nature Geoscience, human emissions of carbon dioxide (CO2) will defer the next glacial period. Researchers use data on Earth's orbit to find a historical warm interglacial period that looks most like the current one, and from this, they may have predicted that the next glacial period would usually begin within 1,500 years from now, and they go on to predict that the emissions have been so high that it will not. Now, the causes of ice ages are not fully understood for either the large-scale ice age periods or smaller ebb and flow of glacial inter of flow of glacial interglacial periods within an ice age. The consensus is that several factors are important. Atmospheric composition, such as the concentrations of carbon dioxide and methane gas. Now, now the specific levels of the previously mentioned gases are now able to be seen with the new ice core samples from the European project for the ice coring in Antarctica known as EPICA, Dome Sea, and Antarctica over the past 800,000 years. And the changes in Earth's orbit around the sun known as the um, Milankovitch cycles, the motion of tectonic plates resulting in changes in the relative location and amount of continental and oceanic crust on Earth's surface, which affect wind and ocean currents. Variations in solar output, the orbital dynamics of the Earth-Moon system, the impact of relatively large meteorites and volcanism, including eruptions of the supervolcanoes. Now, some of these factors will influence each other. For example, changes in Earth's atmospheric composition, especially the concentrations of greenhouse gases, may alter the climate. While climate change itself can change the atmospheric composition, for example, by changing the rate at which weathering removes CO2. CO2. Now, Marine Ramo, William Ruderman, and others propose that the Tibetan and the Colorado plateaus are immense CO2 scrubbers with the capacity to remove enough CO2 from the global atmosphere to be a significant causal factor of the 40 million year Cenozoic cooling trend. Now, they further claim that approximately half of their uplift and CO2 scrubbing capacity occurred in the past 10 million years ago. Now, there is evidence that greenhouse gas levels fall at the start of ice ages and they rose during the retreat of the ice sheets. But it is difficult to establish the cause and effect for this. Um, greenhouse gas levels may also have been affected by other factors which have been proposed as causes of ice ages, such as the movement of continents and volcanism. Now, the snowball Earth hypothesis maintains that the severe freezing in the late Paleo Proterozoic was ended up by an increased level in CO2 levels, so in the atmosphere, mainly from volcanoes, and some supporters of snowball Earth argue that it was caused in the first place by reduction in atmospheric CO2 levels. The hypothesis also warms warns of future snowball Earths. In 2009, further evidence was provided that changes in solar insolation provide the initial trigger for Earth to warm after an ice age, with secondary factors like increases in greenhouse gases accounting for the magnitude of the change. Now, the geological record appears to show that ice ages start when the continents are in position with block or reduce the flow of warm water from the equator to the poles and thus allow ice sheets to form. The ice sheets increase Earth's reflectivity and thus reduce the absorption of solar radiation, with less radiation absorbed in the atmosphere. Cools the cooling allows the ice sheets to grow, which further increases reflectivity in a positive feedback loop. The ice age continues until the reduction in weathering causes an increase in the greenhouse effect. There are three main contributors from the layout of the continents that obstruct the movement of warm water to the poles. A continent sits on top of a pole, as Antarctica does today. Um, a polar sea is almost landlocked, as the Arctic Ocean is today. A supercontinent covers most of the equator, as Rodinia did during the Cryogenian period. Since today's Earth has a continent over the South Pole and an almost landlocked ocean over the North Pole, geologists believe that Earth will continue to experience glacial periods in the geologically near future. Now, some scientists believe that the Himalayas are a major factor in the current ice age because these mountains have increased Earth's total rainfall and therefore the rate at which carbon dioxide is washed out of the atmosphere, decreasing the greenhouse effect. The Himalayas formation started about 70 million years ago when the Indo-Australian plate collided with the Eurasian plate, and the Himalayas are still rising by about 5 mm per year because the Indo-Australian plates are still moving at 67 millimeters millimeters or something like that a year. The history of the Himalayas broadly fits the long-term decrease in Earth's average temperature since the mid Eocene 40 million years ago. And another important factor to ancient climate regimes is the variation of ocean currents, which are modified by current continent position, sea levels, and salinity, as well as other major factors. They have the ability to cool, e.g., by aiding the creation of the Antarctic ice, and the ability to warm, e.g., giving the British Isles a temperature as opposed to a boreal climate. Um, the closing of the Isthmus of Panama about 3 million years ago may have ushered in the present period of strong glaciation over North America by ending the exchange of water between the tropical Atlantic and the Pacific Oceans. Now, the analysis suggests that ocean current fluctuations can adequately account for recent glacial oscillations. During the last glacial period, the sea level fluctuated 20 to 30 meters, 66 to 98 feet above sea level, as water was sequestered, primarily in the northern hemisphere ice sheets. Now, when ice collected and the sea level dropped sufficiently, flow through the Bering Strait, the narrow straight sheet. Hold on here. I'll put this down and open this up. Okay, so yeah, I'm getting kind of hungry here. Here. When ice collected and the sea level dropped sufficiently, flow through the Bering Strait. The narrow strait between Siberia and Alaska is about 50 meters, 165 feet deep today, and it was reduced and resulting in increased flow from the North Atlantic. Um, Now this realigned the thermohaline circulation in the Atlantic, increasing heat transfer into the Arctic, which melted the polar ice age accumulation and then reduced further continental sheets. The release of water raised sea levels again, restoring the ingress of colder water from the Pacific with an accompanying shift to northern hemisphere ice accumulation. According to a study published in Nature in 2021, all glacial periods of ice ages over the last 1.5 million years ago were associated with northward shifts of melting Arctic icebergs, which which changed ocean circulation patterns, leading to more CO2 being pulled out of the atmosphere. The authors suggest that this process may be disrupted in the future as the Southern Ocean will become too warm for the icebergs to travel far up north, far enough to trigger any changes. Matthias Cole's geological theory of ice age development was suggested by the existence of an ice age covering the Tibetan plateau during the ice ages, the last glacial maximum. According to Cole, the late tectonic uplift of Tibet past the snow line has led to a surface of 2,400,000 square kilometers, changing from bare land to ice with a 70% greater albedo. The reflection of energy into space results in a global cooling, triggering the Pleistocene ice age. And because this highland is at such a subtropical latitude, with 4 to 5 times the insulation of high latitude areas, what would be Earth's strongest heating surface has turned into a cooling surface. So, excuse me. No, Cole explains the interglacial periods by the 100,000 year cycle of radiation changes due to variations in Earth's orbit. This comparatively insignificant warming, when combined with the lowering of the Nordic inland ice sheet or the areas in Tibet due to the weight of the superimposed ice load, has led to the repeated complete thawing of the inland ice areas. The Milikonovich cycles are a set of psychic variations in the characteristics of Earth's orbit around the sun. Each cycle has a different region or a different length, so at sometimes their effects reinforce each other, and at other times they partially cancel each other out. Now, there is strong evidence that the Milikonovich cycles affect the occurrence of glacial and interglacial periods within an ice age. Now, the present ice age is the most studied and best understood, particularly in the last 400,000 years. Since this is the period covered by ice cores that record atmospheric composition and proxies for temperature and ice volume, within this period, the match of glacial and interglacial frequencies into the Milikonovich orbital forcing periods is so close that the orbital forcing is generally accepted. The combined effects of the changing distance to the sun, the precession of Earth's axis, and the changing tilt of Earth's axis redistributes the sunlight received by Earth. Of particular importance are changes in the tilt of Earth's axis, which affect the intensity of seasons. For in July at 65 degrees north latitude varies by much, as 22 to 450 M2 to 550 WM2, whatever the fuck that means. It's widely believed that ice sheets advance when summers become too cold to melt all of the accumulated snowfall from the previous winter. Now some believe that the strength of the orbital forcing is too small to trigger any glaciations, but feedback mechanisms like CO2 may explain this mismatch. While Milikonovich Forcing predicts that cyclic changes in Earth's orbital elements can be expressed in the glaciation period, additional explanations are necessary to explain which cycles are observed to be most important in the timing of glacial interglacial periods. In particular, during the last 800,000 years, the dominant period of glacial interglacial oscillation has been around 100,000 years, which corresponds to changes in Earth's orbital eccentricity and orbital inclination. Yet, this is by far the weakest of the three frequencies predicted by Milikonovich. Now, during the period 3 million to 8 million years ago, the dominant pattern of glaciation corresponded to the 41,000 year period of changes in Earth's obliquity, which is the tilt of the axis. Um, the reasons for dominance of one frequency versus another one are poorly understood and an active area of current research. But the answer probably relates to some form of resonance in Earth's climate system. Recent work suggests that the 100,000 year cycle dominates due to dominates increased southern pole sea ice age, increasing total solar reflectivity. So the traditional Milikonovich explanation struggles to explain the dominance of the 100,000 year cycle, the 100,000 year cycle over the last 8 cycles that we experienced for ice ages. Um, Richard Muller, Gordon J. F. McDonald, and others have pointed out that these calculations are for a two-dimensional orbit of Earth, but the three-dimensional orbit also has a 100,000 year cycle of orbital inclination. They propose that these variations in orbital inclination lead to variations in insolation as Earth moves in and out of known dust bands in the solar system. Now, this is a different mechanism to the traditional view that the predicted periods over the last 400,000 years are nearly the same, but the Muller and McDonald theory in turn has been challenged by Jose Antonio Real. Now, William Ruderman has suggested a model that explains the 100,000 year cycle by the modulating effect of eccentricity. Um, a weak 100,000 year cycle on the precession of 26,000 year cycle combined with greenhouse gas feedbacks in the 41,000 and the 26,000 year cycles. Yet another theory has been advanced by Peter Hubers, who argued that the 41,000 year cycle has always been dominant, but that Earth has entered a mode of climate behavior where only the second or third cycle triggers an ice age. Now, this would imply that the 100,000 year periodicity is really an illusion created by averaging together cycles lasting 80,000 and 120,000 years. This theory is consistent with a simple empirical multi-state model proposed by Didier Palier. Palier suggests that the Pleistocene glacial cycles can be seen as jumps between three quasi-stable climate states. The jumps are induced by the orbital forcing wall in the early Pleistocene. The 41,000 year glacial cycles resulted from jumps between only two climate changes. A dynamical model explaining this behavior was proposed by Peter Ditlevsen, and this is in support of the suggestion that the Pleistocene glacial cycles are not due to the weak 100,000 year eccentricity cycle, but a non-linear response to mainly the 41,000 year um, obliquity cycle. Put this down here. Um, there are at least two types of variation when it comes to the sun's energy output. In the very long term, physicists believe that the sun's output increases by about 7% every 1 billion years. Shorter term variations such as sunspot cycles and longer episodes such as the Maunder minimum, which occurred during the coldest part of the Little Ice Age. Um, Now, the long-term increase in the sun's output cannot be a cause for the ice age or of the ice ages. Now, the volcanic eruptions may have contributed to the inception and or the end of ice age periods, but at different times, the paleoclimate carbon dioxide levels were 2 or 3 times greater than they were today. Um, Volcanoes and movements in continental plates contributed to the high amounts of CO2 level in the atmosphere. Carbon dioxide from volcanoes probably contributed to periods with highest overall temperatures. One suggested explanation of the Paleocene Eocene thermal maximum is that undersea volcanoes released methane from clathrates, and thus they caused a large and rapid increase in the greenhouse effect. Now, there appears to be no geological evidence for such eruptions at the right time, but this does not prove that they did not happen. The current geological period of the Quaternary, which began about 2.6 million years ago, and it extends into the present, marked by warm and cold episodes, phases called glacial Quaternary Ice Age, but which has been lasting about 100,000 years, and warm phases called the interglacials, lasting 10,000 to 15,000 years. The last cold episode of the last glacial period ended about 10,000 years ago. Earth is currently in an interglacial period of the Quaternary called the Holocene. Um, Now, the major glacial stages of the current ice age in North America are the Ilonian, the Eemian, and the Wisconsin glaciation. The use of the Nebraskan, the Afton, the Kansan, and the Yamafuyan stages to subdivide the ice ages in North America has been discontinued by the quaternary geologists and the morphologists. These stages have all been emerged into the pre-Eolian in the 1980s. Excuse me. During the most recent North American glaciation during the latter part of the last glacial maximum, which was 26,000 to 13,300 years ago, ice sheets extended to about 45th parallel north. These sheets were about 3 to 4 kilometers, 1.9 to 2.5 million thick. This Wisconsin glaciation left widespread impacts on the North American landscape. The Great Lakes and the Finger Lakes were carved by ice deepening the old valleys. Now, most of the lakes in Minnesota and Wisconsin were gouged out by glaciers and later filled up with glacial melt waters. The old Tias River drainage system was radically altered and largely reshaped in the Ohio River drainage. Other rivers um, were dammed and diverted to new channels, such as the Niagara Falls, which formed a dramatic waterfall and gorge. And when the water flow encountered a limestone escarpment, another similar waterfall at the present Clark Reservation State Park near Syracuse, New York, is now dry. Now, the area from Long Island to Nantucket, Massachusetts, was frozen from glacial till, and the plethora of lakes on the Canadian Shield in northern Canada can be almost entirely attributed to the action of the Ice Age. As the ice retreated and the rock dust dried, winds carried the material hundreds of miles, forming beds of loess many dozens of feet thick in the Missouri Valley. Post-glacial rebound continues to reshape the Great Lakes and other areas formerly under the weight of the Ice Age caps. Um, Now, although the last glacial period and ended more than 8,000 years ago, its effects can still be felt today. For example, the moving ice carved out the landscape in Canada, and you can see the Canadian Arctic Pelago, the Greenland, northern Eurasia, and Antarctica. The erratic boulders, till, drumlins, eskers, fjords, kettle lakes, moraines, cirques, horns, etc., are typically features left behind by the glaciers. The weight of the ice sheet was so great that they deformed Earth's crust and mantle. After the ice sheets melted, the ice covered land rebounded due to the high viscosity of Earth's mantle. The flow of mantle rocks, which controls the rebound process, is very slow at a rate of about centimeter per year near the center of the rebound area today. Now this picture was taken in Scandinavia, and here Scandinavia exhibits some of the typical effects of the ice age glaciation, such as fjords and lakes. And you can see that right there. Now, during glaciation, water was taken from the oceans to form the ice at such high latitudes. Thus, global sea level dropped by about 110 meters, exposing the continental shelves and forming land bridges and between the land masses for animals to migrate. Um, During the glaciation, the melted ice water returned to the oceans, causing sea level to rise. The process can cause sudden shifts in coastlines and hydration systems, resulting in a newly submerged lands. Emerging lands, collapsed ice dams, resulting in salination of lakes, new ice dams, creating vast areas of fresh water and a general alteration in regional weather patterns on a large temporary scale. It can even cause temporary reglaciation, and this type of chaotic pattern of rapidly changing land, ice, salt water, and fresh water has been proposed as the likelihood model for the Baltic and Scandinavian regions, as well as much of the central North America at the end of the last glacial maximum, with the present day coastlines only being achieved in the last few millennia of prehistory. Now, also, the elevation of Scandinavia submerged the vast continental plain had been existed under much of what is now the North Sea, connecting the British Isles to continental Europe. Now, the redistribution of ice water on the surface of Earth and the flow of mantle rocks causes changes in the gravitational period, as well as changes in the distribution of the monumental of inertia of Earth. Um, these changes to the moments of inertia result in change in the angular velocity axis and wobble of Earth's rotation. Um, now the the weight of the redistributed surface mass loaded the lithosphere, and it caused it to flex and also induce stress within Earth. Now, the presence of the glaciers generally suppress the movement on the moment of faults below during deglaciation, and and faults experience accelerated slip, triggering any earthquakes that we sometimes get. Earthquakes triggered near the ice margin may in turn accelerate the ice calving and may account for the Heinrich events. As more ice is removed near the ice margin, more intraplate earthquakes are induced, and this positive feedback may explain the fast collapse of the ice sheets. Now, in Europe, glacial erosion and isostatic sinking from the weight of ice made the Baltic Sea, which before the ice age was all land drained by the by the Eridanus River. Um, Now, based on the past estimates for interglacial durations of about 10,000 years, there has been some concern in the 1970s that the next glacial period would be imminent. Human impact is now seen as possibly extending what would already be an unusually long warm period. Ice ages go through cycles of about 100,000 years, but the next one would be avoided due to human carbon dioxide emissions, according to Stephen Barker out of Cardiff University. Without human interference, the next glaciation of the Earth would occur within the next 11,000 years, and it would end in about 66,000 years. 66,000 years time. Um, a 2015 report by the Past Global Changes Project says simulations show that a new glaciation is unlikely to happen within the next approximately 50,000 years, but before the next strong drop in northern hemisphere summer insolation occurs, if either atmospheric CO2 level concentration remains above the 300 ppm, or cumulative carbon emissions exceed the 100,000 pgc, which is gigatons, only for an atmospheric CO2 content below the pre industrial level may a glaciation occur within the next 10 10,000 years. Given the continental progenic CO2 emissions, glacial inceptions is very unlikely to occur in the next 50,000 years because the time scale for CO2 and temperature reduction toward perturbed values in the absence of active removal is very long, and only weak precessional forcing occurs in the next two precessional cycles. Fuck, I'm sweating like a motherfucker. Okay, that is the end of our video. Thanks for joining in. Um, Next week we're gonna do a video on where the fuck am I here? Okay, next week when I get the time, possibly sometime next Saturday or possibly Friday. I'm gonna put a video up on dinosaurs. Um, and that will be our video for next week. So thanks for tuning in to the Ice Age video. There's gonna be more videos on the Ice Age down the line. I just gotta do some more research on my videos um to put up, and we'll go from there. So thanks for tuning in. If you like the live stream video, give the live stream video a like and subscribe to my channel. Rusty the King for more videos like this, and I hope to see you guys. Hope to see you guys some more in the next live stream videos. And thanks for listening and tuning in.